Assalamualaikum and good morning everyone. In this video, I will discuss the solution for the structured question for tutorial 6 or the question from your question bank for topic 6, which is about the alternating current. I will discuss few questions from this topic. Take a look at question number 1. Figure 6.1 shows the variation of current with time for a sinusoidal alternating current. You need to determine the RMS value for the current, the supply frequency, the phase in time interval of 15 milliseconds, and you need to write down the expression for the graph. So referring to the figure 6.1 or referring to the graph given, there are few information that we can get from the graph. The first one is at the y-axis, we have I naught, which is equal to 5 ampere, and at the x-axis we have the period, which is equal to 40 millisecond or 0.04 second. From the period, we get the hidden information, which is angular frequency equal to 1.57.1 radian per second or 50 pi radian per second. Now we want to calculate the RMS value for current or IRMS. We will use the equation of IRMS equal to I naught over Z2. When we substitute the I naught, you will get the value for IRMS, which is 3.54 ampere. For question number 1b, you need to calculate the supply frequency, and you're supposed to use the equation which is related to the period. F is equal to 1 over T. You substitute the period, you will get the frequency or supply frequency, which is equal to 25 Hz. For question number 1C, for the phase in time interval of 15 millisecond, the equation for phase is omega T. So just substitute the value for omega and the T as given, which is 15 millisecond. So you calculate, you will get the phase, which is equal to 2.36 radian. And lastly, to write down the expression for the graph, first you need to identify the general equation for the current versus time graph, which is I is equal to I naught sine omega T. From this general equation, you need to substitute the I naught and omega. So because of I naught is given to us as 5 ampere from the graph, and the omega that we have calculated, which is 50 pi radian per second. So you just substitute 50 pi or 157.1. So you will get the expression for the graph is I equal to 5 sine 50 pi t, where I is in ampere and T is in second. The unit, please don't forget the unit for the expression or equation represent the graph. For question number 2, a 300 ohm resistor is connected in series with a 5 microfarad capacitor. The voltage across the resistor is given by the expression of VR equal to 1.2 cos 2500 T, where VR is in volt and T is in second. You need to write down the equation of the current in the circuit. You need to determine the capacitive reactance and the equation, write down the equation of the voltage across the capacitor. If you refer to the question, this is the arrangement of the capacitor and the resistor, meaning that the circuit is the RC circuit. Okay, and from the question also we get a lot of information such as the R, which is 300 ohm, capacitance 5 microfarad. From the equation of VR, which is equal to 1.2 cos 2500 T, we get the hidden information, which is V naught is equal to 1.2 volt and the angular frequency, which is equal to 2500 radian per second. So first we need to write down the equation of the current in the circuit. We need to use the equation of I, which is equal to VR over R. Substitute the VR and R. So we get the equation for the current in the circuit is equal to 4 times 10 power of negative 3 cos 2500 T. Don't forget to write down the unit where I is in ampere and T is in second. For question number 2b, we need to determine the capacitive reactance. So for the capacitive reactance, we can use the equation of Xc, which is equal to 1 over omega C. We substitute the value for omega, angular frequency, and the capacitance. So we get the capacitive reactance, which is equal to 80 ohms. And lastly, for question number 2c, we need to write down the equation of the voltage across the capacitor, which is Vc. So we write down the general equation for Vc, which is equal to V naught C sine omega t. We need to substitute the V naught C and omega. Because of V naught C, we can calculate the V naught C, which is equal to I naught Xc. Substitute the I naught and the Xc that we have calculated before, and substitute the angular frequency. So we get the equation for voltage across the capacitor, which is equal to 0.32 sine 2500 t, with the unit of V is in volt and t is in second. For question number 3a, when a certain alternating current of 50 Hz is connected to a bulb rate as 12 volt and 6 watt, the bulb is lit up to its normal brightness. Sketch and label current times graph for this alternating current. Okay, from the question, we have few given information, which is frequency 50 Hz. The value for 12 volt and 6 watt is represent the RMS value. So we have the VRMS and the power RMS. And then if you look at here, this is a light bulb. This is a bulb. So it is represent the R pure capacitor, pure resistor circuit, with the equation of current, which is I is equal to I naught sine omega t, the general equation for the current. So we need to sketch and label the current versus time graph. Okay, before we sketch the graph, we need to identify the information at the Y and X component. So first take a look at the X component, what we supposed to get. So referring to the frequency, we can calculate the period, which is equal to 1 over F. We get the period, which is equal to 0.02 second. And from the frequency also, we can calculate the angular frequency, which is equal to 100 pi radian per second. So this is very important because we will label the graph. And for the Y component, we can calculate, we're supposed to have the value for I naught or peak current. To get the I naught, first we need to, from the information given, we can calculate the IRMS from the equation of PRMS equal to IRMS VRMS. We just substitute the value and our IRMS is 0.5 ampere. From the IRMS, then we can calculate the peak voltage or peak current or maximum current, which is equal to 0.707 ampere. When we get the value for I naught and also the angular frequency, we can write down the general equation for the current, which is equal to which is equal to 0.707 sine 100 pi t. And referring to this equation, when we sketch the graph for this alternating current, we can label at the y-axis the value for I naught and at the x-axis the value for the period. And because of this is sine graph, so just sketch the sine graph. This is the labeled current time graph for alternating current. For question number 3b, the voltage source in figure 6.2 has an output of VRMS, which is equal to 100 volt. The angular frequency is 1000 radian per second. You need to determine the current in the circuit, the power supplied by the source, and you need to show that the power delivered to the resistor is equal to the power supplied by the source. Okay, if you refer to the figure 6.2, there are few information that we get from the figure and also from the question. So the first is the VRMS, which is equal to 100 volt, the angular frequency 1000 radian per second, and because of this is R, L, and C circuit. So we have the value for the resistance, which is 40 ohms. The inductance is 50 millihenry, and also the capacitance, which is 50 microfarad. So first, to calculate the current or to determine the current in the circuit, we refer to the IRMS current, IRMS, by using the equation of V, RMS is equal to IRMS times with impedance. Because of this is RLC circuit, so we can calculate the IRMS. But if you look at the information given, there is no value for impedance, Z. So we need to calculate first the impedance by using the equation of ZR square plus with XL minus XC square. And do take note that XL is equal to omega L and XC is equal to 1 over omega C. When we substitute the value, we get the impedance for this circuit is 50 ohm. And now we can substitute the impedance in the equation with the VRMS. So we calculate the IRMS or the current in the circuit, which is equal to 2 ampere. For question number 3B2, we need to calculate the power supply by the source. So for the power supply, we will use the equation of that relate to the average power or real power, which is equal to IRMS, VRMS, and cos phi. Cos phi is power factor, which is the equation is equal to R over Z. So we just substitute the cos phi as R over Z, and then we substitute the value for IRMS that have been calculated in 3B1 and VRMS. So we get the power supply by the source is equal to 160 watt. Okay, for question number 3B, we need to show that the power delivered to the resistor is equal to the power supply by the source. The power delivered to the resistor, meaning that the power that dissipated through the resistor or the power that lost. Okay, so because of that, we will use the equation of power delivered or power dissipated, which is equal to IRMS square R. We just substitute the IRMS and the value for R. We get the power delivered 160 watt, which is equal to the power supply by the source. That's it for the solution for the first 3 questions from the topic 6 alternating current. Thank you for watching, and I hope that you do take care of yourself and stay safe. I wish you all the best and good luck. If you like this video, can you please click the subscribe button, like, and please share this video with your friends. If you leave a comment, I can improve my next video in discussion of the solution for the structured question. Thank you very much.